Hi, hello, welcome to our channel. Today I would like to explain about optical isomerism. Optical isomerism is also belongs to one of the stereoisomerism. Okay, what is the stereoisomerism? Stereoisomerism means the same chemical formula, same structure but different alignment. That is the stereoisomerism. Optical isomerism, our next concept is. Optical isomerism is also another stereoisomerism. Then what is optical isomerism? Okay. In case of optical isomerisms can shows which compounds. That compounds are known as optically active compounds. Okay. The first of all we can discussing about what is optical activity. Optical activity. What is optical activity? Actually definition is a substance which can rotate plane of polarized light. PPL means plane of polarized light, which can rotate the plane of polarized light is called, the substance is called, okay, optical active substance. And that property of that substance, and this property is called optical activity. This is the definition of optical isomerism. Just listen, optical isomerism is also belongs to the first point is stereoisomerism. Stereoisomerism means same formula, same structure, different alignment. And again our next concept, optical activity. What is optical activity? Optical activity means the substance which can rotate the plane of polarized light is called optical active substance. The compound is known as optical active substance, and that property of the substance is called optical activity. The property of the substance is called a optical activity, and then the substance is known as optical active substance. The first of all, what is plane of polarized light? What is plane of polarized light? In case of we have to discussing about the plane of polarized light. Actually, what is plane of polarized light? In case of plane of polarized light, first we have to take in source of the light. In case of source, and here the light radiations will be moved in all directions. Electric field, I mean the plane of polarized light means the first of all we have to discuss source. Consider the source, whether the source, from that source the light will be derived from the source, the light will be oscillate in all directions. It will be oscillates in, the electric field will be oscillates in all directions. This is ordinary light, normal light. Whether this light is passes through the nickel prism, whether the ordinary light means the electric field of this light will be oscillates in all directions, in this direction, in all directions. Okay, and this is the normal light or ordinary light. When this light is passes through nickel prism, and it will be converts into plane of polarized light. Plane of polarized light is known as like this. Plane of polarized light means the electric field oscillates in only one plane. Electric field will be oscillating only one plane like this. This is plane of polarized light. Electric field is oscillates in only one plane. This is plane of polarized light. Are you clear? Okay. I mean, what is plane of polarized light? Light source. From that source, the electric field of light radiations will be oscillates in all directions. Whether this ordinary light is passes through the nickel prism, and it will be converts the plane of polarized light. Plane of polarized light means the electric field will be oscillates in only one plane. That is plane of polarized light. Are you clear? And this plane of polarized light, when incident on this PPL, whether the plane of polarized light is incident on any one of the substance, and this substance rotates this plane of polarized light, it is an optical active substance. That is the definition. The substance which can rotate the plane of polarized light is called optical active substance. The substance which can rotate the plane of polarized light, the plane of polarized light will be rotates, and then that is optical active substance. Okay, and that property is called optical activity. Are you clear? Okay, the first I have giving only one definition. What is the definition? The substance which can rotate the plane of polarized light is called optical active substance. The property is called optical activity. What is plane of polarized light? Plane of polarized light means the ordinary light. In case of ordinary light, this is ordinary light. In case of ordinary light, electric field will be oscillates in all directions. Whether it is passes through a nickel prism, the oscillation of electric field will be in only one plane, that is plane of polarized light. Are you clear? Okay, next. The measure of optical activity. The measuring of optical activity, optical rotation. Measuring of optical rotation. The measuring of optical rotation is done by polarimeter. Polarimeter. The polarimeter is one of the instrument is used for the measuring of optical rotation. Measuring of optical rotation or identification of optical active compound. Optical activity. Clear? Measuring of optical rotation or identification of optical activity. That means the compound is optical active compound or optical inactive compound. That identification is also done by polarimeter. What is polarimeter? Same way, same diagram. In that case, normal light source. Light source means the electric oscillations. The electric oscillations is in all directions. Clear? Electric oscillations in all directions. Whether this oscillation, this ordinary light, okay, is passes through nickel prism. Actually, two nickel prisms are used. Here first nickel prism can converts into plane of polarized light. Plane of polarized light. We are already discussed in previously. And this plane of polarized light is passes through one substance, and here one tube. That tube have the solution. And then it is also, this light is also passes through another nickel prism, second nickel prism, and this first nickel prism is the polarizer. The second nickel prism is acting as an analyzer. Okay, and here it will be gives result. Clear? Here it will be gives result. Are you understand? This is the instrumentation of polarimeter. What is the use of polarimeter? Use of polarimeter, measuring of optical rotation or identification of optical activity. Measuring of optical rotation or identification of optical activity. Then here light source, ordinary light passes through nickel prism. The nickel prism is light is passes through nickel prism is converting into plane of polarized light. Plane of polarized light is passes through solution. Here interactions takes place, and then after it will be passes through another nickel prism acting as analyzer and giving result. Whether the result, what is the result? The plane of polarized light. The plane of polarized light, no change is observed. Plane of polarized light is no change is observed in a result. No change means optically inactive. Optically inactive. Whether plane of polarized light rotates rotates two ways, either right side or left side, either clockwise or anti-clockwise. Okay, and then plane of polarized light will be rotates in right side, and this is the plane of polarized light. It will be rotates in this way. Then it will be rotates in right side or clockwise. Rotate in right side or clockwise, and then the notation is D, and it is optical active compound. The notation is D. Why we have to use the D? The name is dextrorotatory. Dextrorotatory. In a Latin name, dextro means right. In a Latin words, dextro means right. Okay, dextrorotatory. Then that optical active compound, isomer, represented as D. Are you clear? Okay. Whether the result, the plane of polarized light, here I am writing another result, the plane of polarized light, okay, will be rotates left side. This is plane of polarized light. It will be rotates left side direction or anti-clockwise. Left side or anti-clockwise. Okay, and this is known as levorotatory. In a Latin words, levo means left. Then that isomer is known as represented as L. Are you clear? Okay. This is the polarimeter. Next we can observe what are the conditions of optical activity. Okay. Already we can discussing what is optical active substances, what is optical activity, and what is plane of polarized light, and what is polarimeter. Okay. The first one, what is optical activity? Optical active substance, the substance which can rotate the plane of polarized light. Optical active compound, the property is known as optical activity. Plane of polarized light means the electric field oscillates in one plane, that is plane of polarized light. Okay, and then plane of polarized light which rotates in right side direction, dextro, D notation, which can rotates left side, L notation. And in case of conditions of optical activity. Conditions of optical activity, optical active substances. Which substances are known as optical active? By using polarimeter, we have to decide the compound is optical active or not. But generally, some conditions, by using some conditions, we are also decided that the substance is optical active or not. Okay, what are the general conditions? The first condition, chirality, very important one, chirality. Chirality. What is chirality? Chiral molecule or achiral molecule. Whether the molecule is chiral, whether molecule is chiral, it is an optical active. OA means it is a optical active. Whether the molecule is achiral, it is a optical inactive. Whether the molecule is chiral, optical active. Whether the molecule is achiral, optical inactive. The first condition. Actually, the conditions of optical activities are 4 conditions. The first condition, chirality. Chiral molecule, optical active molecule. Achiral molecule, optical inactive molecule. How we can decide the molecule is chiral or achiral molecule? Chiral or achiral molecule. And simple thing, if the molecule have the chiral carbon atoms, if the molecule contains chiral carbon atoms, what is chiral carbon atom or asymmetric carbon atom? Chiral carbon atom or asymmetric carbon atom? Chiral carbon atom or asymmetric carbon atom? What is chiral carbon atom or asymmetric carbon atom? Whether the carbon atom is bonded with different atoms. Carbon have hydrogen, bromine, chlorine, iodine. In that case, the carbon atom, what is the valency of carbon? 4. The carbon is surrounded by 4. And here, hydrogen, bromine, chlorine, iodine. All 4 atoms are different. Whether the carbon atom surrounded by 4 different atoms or 4 different groups, that is chiral carbon. This is the chiral carbon. This is the chiral carbon, and then the total molecule is chiral molecule. Then it is an optical active molecule. Are you clear? Whether the molecule is a chiral molecule, optical active molecule. Whether the molecule contains chiral carbon atom, that is optical active compound. Chirality will be exist. Okay? Clear? And another definition is also there in case of chiral compounds. In another definition, what is that? The molecule, okay, non-superimposable on its mirror image. That is also chiral molecule. Another definition. The first definition, it must be contain asymmetric carbon atom or chiral carbon atom. Another definition for the chiral carbon atom. What is another definition? The first non-superimposable mirror image. It must be contains the non-superimposable mirror images exist. That molecule is chiral molecule. Non-superimposable mirror images exist means, for example, we have to take as one of the tartaric acid. Actually, in case of tartaric acid, COOH, H, CH, bond OH, COOH. This we have to take in one of the example. And here chiral carbon atoms. Where is the chiral carbon atom? This is one of the chiral carbon atom. This is one of the chiral carbon atom. Why? Because in this carbon atom, COOH, OH, H. COOH, OH, H. 2 chiral carbon atoms are there. And again, non-superimposable mirror images exist. I mean, COOH, H, OH, OH, H, COOH. These 2 are mirror images and these 2 are non-superimposable. I mean, whether you can consider this compound and this compound have a non-superimposable mirror image, another pair will be exist for this compound, then this compound is optical active. Again, we can decide it, we have to consider this compound, this molecule also having non-superimposable mirror images exist, then this is also optical active and mutually optical active. Actually, this pair is enantiomers. Okay, we can discuss the enantiomers in next class. Okay, this is the non-superimposable mirror image. This molecule having the chiral carbon atom, this is also chiral carbon atom, and it is also having the non-superimposable mirror image. This is mirror image and non-superimposable. Okay, then this is optical active, and again this is also optical active. Here also chiral carbon atoms are exist. Clear? Okay, the first point is over. Chirality. Conditions of optical activity. First component is chirality. Molecule must be chiral molecule, optical active. A chiral molecule, optical inactive. For example, CH4, compulsory optical inactive. Why? Because all 4 valences of carbon is surrounded by same atoms. Clear? Okay. Next we observe second condition. Second condition, that is the second condition. It must have non-superimposable mirror images. Second condition. I am already discussed. Chirality, another definition is also it must have non-superimposable mirror images. If the molecule have the non-superimposable mirror images exist, the molecule is also known as chirality. I am already discussed. I mean 2 points are over. Very clear? 2 points are over. It must be have non-superimposable mirror images. Maybe the previous example, tartaric acid. Are you clear? Okay. Okay. And then Third example, third condition. Third condition. What is the third condition? Chirality is over. Okay. First two conditions are same. Third, fourth conditions are also same. What is the third condition? Lack of symmetrical elements. Lack of symmetrical elements. Lack of symmetrical elements. I mean the molecule does not contain any type of symmetrical elements. Actually, symmetrical elements, only three types of symmetrical elements are there. What are they? Plane of symmetry, plane of symmetry, and axis of symmetry, axis of symmetry, center of symmetry or point of symmetry. Three types of symmetrical elements are there. Okay, plane of symmetry, axis of symmetry, center of symmetry. What are the operations? Plane of symmetry, mirror images, mirror images. Axis of symmetry, operation, rotation. Center of symmetry, operation, inversion, inversion. Okay, we can consider one of the example, and previously we have to discussed COOH, C bond OH bond OH, C bond OH bond OH bond COOH. In this example, plane of symmetries exist, and in this example, chiral carbon atoms are exist. This carbon atom having chiral carbon atom. I mean this carbon atom is a chiral carbon atom. Why? Because OH, H, COOH, this group. Then it is a chiral. It is also chiral H, OH, COOH. Again group. But it has a plane of symmetry like this. Plane of symmetry. I mean, this is the molecule in one plane, this plane. This is the plane and the molecule like this vertically. Okay, and this plane, the plane of symmetry operation is mirror images. I mean, the plane can divide the molecule in two halves. The two halves are mirror images to each other. And then this is the mirror to this. This is the mirror to this mutually. Then it has a plane of symmetry. It is an optical inactive. Optically inactive. Okay, lack of symmetrical elements. Lack of symmetrical elements. Whether any symmetrical element is exist, it does not optical active. Okay, and again, axis of symmetry. The operation is rotation. Axis of symmetry. Okay, and then here we can observe Me means methyl group. Okay, in this example, okay, we can consider, and this is the square type plane, and here the hydrogen is above the plane and methyl is, I mean this is the 1, 2, 3, 4. 1, 2, 3, 4. On first carbon atom, hydrogen is above the plane, methyl is below the plane. On second carbon atom, methyl is above the plane, hydrogen is below the plane. Third carbon atom, hydrogen is above the plane, methyl is below the plane. Alternatively. Okay, and then we can consider the plane, I mean axis like this. The axis is passes through center like this. Center of the molecule. Whether you can rotate the right side or left side 90 degree. Just you have to rotate the 90 degree. Which molecule is observed? And then this is 1, this is 2, this is 3, this is 4. I mean just it will be rotate like this. Here first carbon atom is exist and it will be rotates. I mean here this is first carbon atom is exist, just it will be rotates. First will be at this position, here first at this position, fourth at this position. Okay, 1, 2, 3, 4. Here 1, sorry, here 1, here 2, here 3, here 4. Here 1, the first carbon, methyl is lower, methyl hydrogen. And here second, methyl is up, above the plane. Sorry. Second, methyl hydrogen. Third, methyl hydrogen. Fourth, methyl hydrogen. And this axis of symmetry is known as C2 axis of symmetry. Means on the rotation of axis can give the same structure, not identical, same, similar structure is observed. Clear? By the rotation of 90 degree. Rotation of 90 degree angle. And this is C2 axis of symmetry. Actually, axis of symmetry will be indicates Cn, where n equals to 360 by theta. Here we can rotate the we rotate the molecule in 90 degree. Then we can substitute n equals to 360 by theta, 360 by 90. Sorry, not C2, C4 axis of symmetry. C4 axis of symmetry. Okay. And again, center of symmetry. Center of symmetry means inversion. Inversion. What is the inversion? Methyl hydrogen, COOH and hydrogen, COOH hydrogen, H methyl. Okay. And here 1, 2, 3, 4. Center of symmetry. Here we can consider one of the center. Inversion means in opposite directions, at same distance, in opposite direction, in opposite sides, identical groups are observed. That is the center of symmetry. Here we can observe the center. Okay. And here COOH group is there, first carbon atom. This will be known as first. It has a COOH group. And the third carbon atom, it has a COOH group. And the center, from this center to COOH group, some distance. And the same distance is observed in opposite direction. In opposite sides, at same distance, identical groups are observed. Then the center is known as center of symmetry. That is the inversion. This is opposite sides. Opposite side, same distance. Okay, this is the center. Here COOH from this. At the same distance, another COOH is there in opposite side at same distance. COOH, COOH. Not only COOH, here methyl, here methyl. The center is center of symmetry. Are you clear? Okay. These are the plane of symmetry, axis of symmetry, center of symmetry. Okay. Okay. And again, fourth condition. Fourth condition, third condition, almost similar. What is the fourth condition? Must be absence of plane of symmetry. Must be absence of plane of symmetry. How we can, why I am giving the separately the point. Already I am giving here the plane of symmetry, whether the molecule contains the plane of symmetry does not exist. But here I am not giving exactly plane of symmetry. In this point, lack of symmetrical elements. Here in this point we can describe base for all three symmetrical elements. In case of plane of symmetry, in case of axis of symmetry, in case of center of symmetry. Whether any type of symmetrical element is exist, the molecule is optically inactive. That will be discussed in third point. Whether plane of symmetries exist, optical inactive. Whether axis of symmetries exist, optical inactive. Whether center of symmetries exist, optical inactive. But why we have to decide, we can describe another fourth point is absence of plane of symmetry. Why? Okay, are you understand? Just listen. The first one is chirality. Okay, it must be have not superimposable mirror images. Second point. Third point, lack of symmetrical elements. Whether any type of symmetrical element is exist on any molecule, it is an optical inactive. But I am giving another point is plane of symmetry absent. Why? Because here I am giving one example. Okay, one example. In this example, HCl. Cl, H, H, H. I do understand. Here another example. In this case, okay, above this one, above the plane. Just we can recognize, we can understand. Like this. Above hydrogen, above the plane, below the plane, and again here above the plane, below the plane, above the plane, below the plane, like this. Okay. In this example, chlorine is above the plane on first and second below the plane. In this example, axis of symmetries exist like this. One axis of symmetries exist. Whether you can rotate this molecule in right side, like this, right side, what happened? Whether you can rotate this molecule in right side like this, okay? What happened? Here I am giving the numbering 1, 2, 3. Okay, and again you can rotate. 2 will be same place. 1 and 3 will be interchanged. 90-degree rotation. Okay. This is 2 and this is 3. This is 1. And again on first carbon hydrogen Cl. On third carbon Cl hydrogen. Are you clear? And here hydrogen. It has an axis of symmetry. C2 axis of symmetry will be exist. But it is optical active molecule. It is very important example. It is an optical active molecule because lack of plane of symmetry. Why? Because here C2 axis of symmetries exist. It does not have plane of symmetry. And again, this molecule can have the non-superimposable mirror image. It has a non-superimposable mirror images exist on this molecule, but it has a C2 axis of symmetry, but not have the plane of symmetry. Because of this point, because of fourth point, this molecule is an optically active molecule. Are you clear? Are you understand? Okay. I'm clearly giving this example. Hydrogen, chlorine, hydrogen. It has a C2 axis of symmetry like this, but it is a optically active molecule. Because of fourth condition, it does not have plane of symmetry. For example, this one, this is also having C2 axis of symmetry like that, and again also having plane of symmetry like this. This plane, this molecule will be exist like this, okay, and then plane will be exist here. This chlorine, mirror image, this hydrogen is mirror image. These two are mirror image, these two are mirror image. Then it have a plane of symmetry. If the plane of symmetries exist, optically inactive. Just you can think like that, whether the molecule have plane of symmetry must be optically inactive. Whether the molecule have the plane of symmetry. The same reason, tartaric acid, COOH, bond COH, bond H, bond COH, bond H, bond COOH. In this example, C2 axis of symmetries exist but optically active. In this example, chiral molecules are exist but it is an optical inactive. Why? Here plane of symmetries exist. Because of existence of plane of symmetry, optically inactive. Because of fourth condition is very important condition. Okay, whether molecule have the plane of symmetry along with chiral carbon atoms, that is optical inactive. whether the molecule have the chiral carbon atoms, but it exists plane of symmetry, it is an optical inactive, optically inactive. In this case, whether any molecule have other symmetrical elements, okay, at that time it does not have plane of symmetry, it is optical active molecule.